Hi and welcome to another LeetCode video. Today we're looking at LeetCode 3370, smallest number with all set bits. It's an easy problem, but if you've seen any of my other videos, you know that they are an excellent opportunity to practice the interview process, which is what we're going to do. So first, let's try to understand the problem, right? So we're given a positive number n, and our task is to return the smallest number x greater than or equal to n, such that the binary representation of x contains only set bits. Okay, cool. And the constraint is that our number n is at least 1 or larger. Cool. Wonder why they didn't allow a 0. Would also work, but it's 1 or larger, fine. Now, here's an example. So n equals 5, the output would be 7. And that's because the binary representation of 7 is 1, 1, 1. And the binary representation that is smaller, that has all bits set, would be 2, 2. But that would be 2 times 2 to the power of, I don't know if you're familiar with the bits. If you're not, then this might be informative. So the way to convert a binary number into decimal is just to start from the right side, if it's the least significant bit there. And basically what you do is you multiply the bit by a power of 2 raised to the position of the bit in the bit string. So here we have at index 0, that's from the end, index 0, we have 1 times 2 to the power of 0, that would be 1, right? Decimal value 1. And then we have 1 times 2 to the power raised 2 to the first power, because this is at index position 1. That would be 2, right? So binary representation 1, 1 is equal to the decimal representation of 3. And if we had a 0 here and a 1 here, this would become 0 times 2 to the power of 2 plus 1 times 2 to the power of 3, which is 8. So this would be 8 plus 0 plus 2, which of course would be 11, right? This is the binary representation of 11. Now, our value x needs to have only set bits, right? So we probably have to start with a value of x and then compute, well, we have to compute, you know, all the different numbers that are smaller and pick the first one that is larger or equal to than our value n. So I think that's the approach that I'm going to take. I'll have a loop, and that loop probably takes logarithmic time, because of every step of a loop we're going to add 1 bit, which is the same as multiplying the number by 2. And yeah, once we meet the condition that our x is larger or equal than n, then we just return that value. So that'll be O of log n time and O of 1 space. So we start with our value x. I'm just going to call this result. And since n is 1, that means the smallest result value can also only be 1. Decimal value 1 is the binary value also with just the 1 bit set, right? So now, while result is smaller than n, we're going to perform an operation. Well, we're going to multiply our result by 2 times 2, and we're going to add, are we going to add 1 to it? Yeah, and we're going to add 1 to it. So, and the reason would be, so let's speak in decimal. So we have 1. Now we multiply it by 2 and add 1. So that would be 3 in decimal. But in binary, it would be 1, 1. That's exactly what we want. So now if we have to make another iteration, we will have again to multiply this by 2 and add 1. So we had 3 before, but now we multiply it by 2 and add 1. So that will be 7 in decimal. But in binary, it would be 333. So we're actually achieving exactly what we want. We are adding one more bit to our result. And that should be the entire code. So I'm now running it through the tests. It passes, which is nice. And I'm now going to submit it to see if it passes all of the tests. And it does.